Welcome back to the deep dive. You've shared a stack of truly foundational source material with us today.
We have.
And our mission really is to cut straight to the core. We want to extract the essential knowledge you need to be deeply informed about topics that, they usually get filed under philosophy.
Right, but they're not just philosophical. They underpin everything we talk about today. AI, life, consciousness, even the basic laws of physics.
It's all connected.
These are not light sources. We're engaging with a philosophical dialogue that uses the relationship between humans and robots to achieve something, well, something pretty profound.
Which is a complete non-mechanistic understanding of time.
Exactly. This is less about specific physics equations and far more about understanding the limits of our own knowledge, the limits of our own existence, really.
Okay, let's unpack this. We're embarking on a pretty ambitious journey here. Our mission today is to thoroughly examine the philosophical division between what the sources call mechanism and complexity.
And then show how that distinction, once you really grasp it, forces you to completely rethink everything.
Everything from the clocks on our wrists to the possibility of ever building a functional paradox-free time machine.
And we're going to anchor this entire conversation on one central, really imaginative provocation that's posed in your reading.
Let's hear it.
It's simple. We know that complex beings, humans, build mechanisms, robots, but if a robot society achieved true sentience, would they ever, or could they ever, decide to build humans?
And that asymmetry, that question, is the key that unlocks this whole discussion.
It's everything.
That starting premise, it really sets the stakes high immediately. You imagine this advanced robot society, they've mastered engineering, they've perfected their own logic.
Purely rational beings.
Exactly. So why wouldn't they eventually try to reverse engineer their creators? I mean, why isn't the answer simply, well, they just haven't figured out the biological code yet?
And that assumption that it's just an engineering problem is precisely what the source material challenges at its core. To understand why robots wouldn't or couldn't create humans, we first have to establish the difference between what they are and what we are.
This is a question of, what's the term? Ontology.
Ontology, the nature of being. It's not about what something does, but what it is.
So let's define the terms then. On one side, we have mechanism, and our source material aligns this with the robots.
Right. Mechanism is defined here very, very strictly as a non-living system. The single defining characteristic is predictability.
Predictability and reversibility.
And reversibility, yes. Every internal component, every single interaction is predetermined. You give it a set input, and the reaction is known. It's calculable.
Like a pool table. You hit the cue ball at a certain angle and speed, and physics dictates the outcome perfectly.
A perfect analogy. And crucially, the sources explicitly define mechanisms as not complex. They might be incredibly complicated, but they are not complex in this philosophical sense.
Okay, that's an important distinction we need to come back to.
Yeah.
So on the other side, there is complexity, and that's defined by us. Humans, life, living things.
Complexity is the non-mechanistic, non-predictable system. Life, according to these sources, begins, and I'm quoting here, at a certain level of complexity.
And unlike mechanisms, which are bound by those deterministic input-output rules,
living beings exhibit behaviors that just cannot be fully calculated or predetermined. They are subject to spontaneous, non-localizable, and this is the most important word, irreversible change.
This brings us right to the core thesis of the whole thing, the fundamental asymmetry. We, the complexities, can certainly create mechanisms. We do it all the time. We build AI, we build clocks, we build cars.
The flow goes from complexity to mechanism.
That is the one-way street.
And the essential claim is that the street cannot be traveled in reverse. A non-complex mechanism is, well, it's categorically incapable of generating or creating true complexity, true life.
But I have to push back on that because, the listener hears constant promises about sophisticated AI. I mean, if we give a robot access to all the biological data in the world, if we give it nanobots and self-assembly code, isn't it just a matter of time and processing power before it cracks the code of life?
That's the classic technological optimism, and it's completely understandable. But the philosophical argument here is that the barrier is not technological, it's ontological.
A barrier in its very being.
Yes. The capacity for creation is bound by the capacity for understanding. A mechanism, because it exists within a purely deterministic, reversible framework, literally cannot understand non-determinism, irreversibility, or self-development.
So no amount of mechanical sophistication can cross that divide.
It's like asking a calculator to understand joy. It can process all the inputs that lead to the word joy appearing on its screen, but it cannot experience the concept that grounds the word. It's a different category of existence.
So it's not about the number of parts, which brings up that critical distinction you mentioned. How do we separate something that is merely complicated from something that is truly complex? Because modern AI models are complicated to an extreme degree.
And that distinction is paramount. Let's use an analogy to make it clear. Think of the most complicated grandfather clock imaginable.
Yeah.
I mean, one with billions of interconnected gears, springs, and levers. That clock is unbelievably complicated. You could spend a lifetime charting its functions.
But it's still fundamentally reducible.
Exactly. Every movement, every tick, every reaction is traceable to a definable input and a known physical law. If you introduce a fault, a problem,
You can find the broken gear, you can locate the problem.
its behavior is predictable and deterministic. It's a closed system, even if it's a massive one.
Right.
Now, compare that to a complex system like a single cell or a growing child. It is non-reducible.
Meaning you can't trace all of its actions back to a single definable input.
You can't. And if you try to analyze it, the very act of analysis changes the system. It exhibits self-development, internal, irreversible changes that cannot be mapped entirely by external observation.
So the core insight is that complication deals with the quantity of parts.
While complexity deals with the quality of existence. Specifically, that capacity for non-deterministic, irreversible change. That's the magic ingredient.
So even if our robot society built a perfect, biologically accurate, mechanical replica of a human being, I mean, atom for atom, every nerve, every simulated chemical reaction, it would still fail the test.
It would fail. It would be an incredibly, unbelievably complicated mechanism, but it wouldn't be complex.
Because it lacks that inherent capacity for non-calculable, irreversible existence.
Precisely. They would have created a sophisticated mechanism that mimics complexity, but which, under the hood, is still reducible to a set of reversible equations. For the robot, everything is fundamentally reversible, and that's a critical point we'll return to when we discuss time. The inability to even conceive of an irreversible, non-reducible system prevents them from ever creating one. It's outside their operating parameters.
Let's follow that impossibility further then. If the asymmetry holds and robots cannot create life, let's introduce the hypothetical encounter. That highly advanced robot community stumbles across us, humans. They're utterly messy, non-predictable creators.
A fascinating thought experiment.
How does their mechanistic worldview, their epistemology, as the source calls it, how they know what they know, how does that constrain their reaction to us?
Well, their entire world is one of pathic systems. Their whole horizon of understanding is limited to mechanisms where behavior is always predictable and where any deviation
Is a bug, an error that can be fixed.
an error that can be localized. They see the universe as pure, perfect clockwork.
So they would look at a human being, crying one minute, laughing the next, holding contradictory political beliefs, constantly making suboptimal decisions from a logical standpoint, and their entire framework would just seize up.
They would have to interpret everything through the mechanical lens because that is the only lens they possess. They can perfectly analyze a rocket engine, a supercomputer, or a washing machine.
They have the capacity for infinite analysis and replication of any mechanism.
But when they're faced with the human, they are confronted with a system that resists reduction, that refuses to be a simple machine.
And this leads them to the only possible conclusion within their system of logic. Humans are a faulty machine.
Yes, exactly. Humans are interpreted as mechanisms that are failing to function correctly. But this is where their philosophical failure deepens. It's not so simple.
Oh, sorry.
In a standard mechanism, a fault is localizable. If your car breaks down, you can find the broken wire, the seized piston, the bad sensor. The error is concrete and determinable.
Right, you can point to it.
But when analyzing a complex being, a human, they would be searching for a physical, determinable fault to explain things like creativity or love or even irrational anger.
They'd be looking for the love circuit or the sadness gear.
Precisely. They would endlessly search for a non-existent, localizable error in the human system to explain our unpredictability. They might scan our brains, identify chemical flows, map every single neuron.
But they would never find the simple, specific mechanism that is broken.
Why? Because the human isn't actually a mechanism. The non-mechanistic behavior is not a fault. It is the fundamental nature of complexity. It's a feature, not a bug.
So their analysis is not just complicated, it's philosophically doomed from the start. They are looking for a broken wire in a system that doesn't use wires in that way.
And this makes humors an insoluble curiosity, a profound paradox for their metanistic world understanding.
Our very existence would be a logical contradiction to them.
It would be. The existence of a living being contradicts their entire framework, forcing them to conclude that the universe contains an error that cannot be resolved, a failure that cannot be localized. It's an epistemological crisis for the robots.
Okay, this is the moment to flip that mirror back onto ourselves. This is maybe the most uncomfortable part of the source material. We are complexities. We know we aren't just robots, yet we constantly fail to explain our own functioning, like consciousness or self-awareness. Why do we, the complexities, also fall into the same trap?
This is the critical insight, and it's a tough one. Humans systematically apply a mechanistic worldview to themselves.
We try to understand ourselves as robots.
We do. We use models rooted in classical physics, engineering, and computation to explain our own being.
We use the language of determinism and input-output to explain a phenomenon that we've just defined as fundamentally non-deterministic and non-reducible.
Precisely. We are great at building machines because we understand their reversibility and predictability. That's our comfort zone. But when we look internally, we reduce psychological states, emotions, memory
to simple hardware glitches or chemical imbalances.
Exactly. Imbalances that we assume can be corrected with a simple input, like a drug or a piece of cognitive restructuring. We fail to grasp the non-reducibility and the irreversibility of our own complex nature.
So we succeed at engineering.
But we fail at self-explanation. It's the great human paradox.
Let's dwell on that for a second. The mechanistic worldview it's convenient, isn't it? It gives us a sense of control. If my memory is fading, I prefer to think of it as a simple hardware glitch I can fix.
Of course, that's much less scary than acknowledging it is an irreversible process inherent to your complex living existence. It simplifies the terrifying reality of non-determinism.
And when that mechanistic model inevitably fails to explain life, when we can't reduce creativity or despair to a simple circuit diagram, what do?
We use placeholders. We invent words to cover the gap in our knowledge.
The placeholders being the terms we use when our knowledge runs out. Metaphors, really, like life, complexity, emergence.
Or the older, more descriptive terms like spirit or soul. The source dialogue is very clear on this. These are not explanations.
They're just labels for the mystery.
They are merely signals of our epistemological limits. They indicate the boundary where our chosen mechanistic framework breaks down, and we have to resort to poetry or metaphysics to describe the non-calculable. The human paradox is that we possess the complexity, but we choose the robot's limited framework to try and explain it.
That sets up the perfect philosophical bridge. The conflict between our complex nature and our mechanistic way of thinking has a consequence far beyond AI and consciousness. It dictates how we understand the nature of time itself.
Let's explicitly connect our previous point to temporality. We established that a mechanism is defined by reversibility.
Right. If you can define the state of a machine now, you can mathematically reverse all the processes and perfectly reconstruct its state at any point in the past.
And if the process is perfectly reversible, then time is excluded per se from the mechanistic worldview.
The mechanism is, philosophically, timeless.
It has no inherent time. It just exists in a state that can be moved forward or backward along a predictable path.
And this timelessness, this assumption of reversibility, is the exact foundational error required for the idea of the time machine paradox to even exist in the first place.
It's the only reason we can even conceive of it. The time machine, as you see it in science fiction and even in physics hypotheticals, is a physical device, a mechanism.
A machine that can be run forwards, backwards, or at any speed, moving between moments in what we call a temporal dimension.
It treats time as an external dimension, like space, through which the mechanism travels.
But the very existence of the machine contradicts the nature of time travel itself, the time machine being a mechanism.
It is defined by its ability to be reversible and repeat its cycles.
So that's the core contradiction.
It is. For the time machine to function as a controllable travel device, it must presuppose that the object traveling is timeless, that it is not subject to irreversible change, and that the medium it travels through, time, is also a reversible, navigable dimension.
It requires the system to be timeless as a prerequisite for engaging with time.
which is a complete paradox. If the time machine is running backward in time, it must perfectly reverse its internal state and its external environment. If its state can be perfectly reversed,
Then no true time has passed for the mechanism itself. If the mechanism is timeless, what is it actually traveling through?
it's traveling through a concept of time that is fundamentally mistaken. It confuses time with a dimension of space. If time were merely a dimension and the mechanism were reversible, then going backward would be philosophically identical to walking backward down a hallway.
But if time is defined by irreversible change, as I suspect we're about to discuss, then reversing a physical process isn't just technologically difficult.
It's ontologically impossible. It's a contradiction in terms.
The source material suggests that within this mechanistic framework, the concept of the time machine is suitable only for, and I'm quoting, fairy tales, myths, or science fiction.
It has to be. We must discard the idea entirely if we accept the non-mechanistic nature of reality.
So the whole concept of a time machine only exists because we humans habitually default to the mechanistic explanation for everything.
It is the ultimate expression of that belief. The belief that everything, even existence itself, must be a complicated but reversible mechanism that can simply be rewound like a videotape.
So if looking outwards at the mechanisms of the universe only yields this timeless, reversible concept, we have to abandon that objective view. The source material instructs us to look inwards at the living individual to find the true nature of temporality.
We shift methodologies. We go from physics to existence. Time, in this philosophical view, is not some external cosmic force ticking away in the background.
It is rooted in the individual's development and existence as a living being.
Yes. Living beings, complexities, are defined as, the German term is wonderful, Zeithabenden Individuen.
Which translates to,
Time-having individuals. We have time. It's a property of our being, not something we move through.
I appreciate that clarification. And the crucial point here, distinguishing life from mechanism, is irreversibility.
Irreversibility is the very substance of time. If you could rewind a process perfectly, then no time would have passed in any meaningful sense. Time is simply the accumulation of changes that cannot be undone or re-entered.
Let's use that powerful example from the sources. Trying to mentally re-enter a past state. Say you try to relive the specific feeling, the knowledge, the context you had exactly 5 years ago today.
You can recall the facts, sure, you can remember what happened, but you cannot mentally, cognitively, or physically occupy the identical state.
You can't filter the world through the exact same set of experiences and biases you had 5 years ago.
Because you have accumulated irreversible changes, new memories, new context, different neurochemistry, you're physically older, the old you is gone.
I can watch the same movie I loved 20 years ago, but my reaction to it now is necessarily irreversible. I see it through the lens of 20 years of gained knowledge. My new reaction proves that the previous state is lost forever.
And that is the function of time. If it were possible to fully re-enter that previous physical or cognitive state, then your development would be reversible.
And I would just be a mechanism waiting to be wound backward.
But life resists that. The question, what happened, is answered by the fact that the changes are permanent. They're unrewindable. Time passing is not a flow. It is the accumulation of these irreversible changes.
This fundamentally challenges the common assumption that time is a single universal flow. You know, the external cosmic tap giver that sets the rhythm for everyone and everything simultaneously.
That notion of a single external force is another manifestation of the mechanistic worldview. It's always seeking a simple, external, controllable variable.
But here, time is initially individual.
It has to be. Every complexity develops uniquely and irreversibly, according to its own internal developmental processes. My time is not your time, in the strictest sense.
But we do coordinate. We all agree it's Thursday. So why does it feel like we share one single time? How does this concept of individual time lead to the appearance of a shared reality?
It arises through coordination. It's a social construct, not a physical one. Individuals interact, they synchronize their behaviors, and they're exposed to similar external influences like sunlight or seasons.
So we negotiate a shared rhythm for practical, social, logistical reasons.
Exactly. The shared noon is not dictated by an external physical law called time. It is an emergent social reality built on coordination so we can all meet for lunch.
So if I accept this, then the search for some fundamental universal constant that dictates the pace of aging for both a star and a human is It's fundamentally misguided.
It is. That search is the impulse to reduce complex individual phenomena into one simple external mechanistic variable. It's just easier to believe in a grand universal clock than to accept that every person, every cell, every planet is defining its own irreversible path forward, and that we only share time through agreement.
If that's the case, we have to look squarely at the object most associated with that universal flow of time, the clock. Feels almost absurd to ask, but
Yeah.
what is a clock actually doing?
It's a necessary stupid question, because the common belief that the clock measures time is the source of all our temporal confusion.
The clock is definitively not a time-measuring device,
It can't be.
because time isn't measurable in that way. It's not a physical quantity that exists externally.
Exactly. You can't build a time sensor and hide it inside a watch. The clock's entire essence, all it does is depict a periodic process.
Whether it's the physical oscillation of a pendulum, the electronic pulse of a quartz crystal, or the simple rotation of hands on a face.
It is depicting a fixed, repeating sequence. That's all.
And a periodic process, by our own definition from earlier, is timeless in itself.
It must be. The whole function of the clock is that the same thing happens over and over and over.
Yeah.
If you look purely at the abstract periodicity, the second hand moving 360 degrees, you cannot tell how often it has already occurred.
Or how much time has passed since the process began.
You only see a mechanism that is designed to be unchanging and eternal in its repetition.
And we extend this same principle to natural cycles, don't we? The rotation of the Earth, the seasons, the orbits of planets. We treat these as giant, predictable, periodic mechanisms.
We rely on their timelessness. If planetary orbits weren't reliably periodic, we couldn't use them to coordinate our calendars. These cycles, the hours, days, years, are simply the most reliable, unchanging mechanisms available to us.
We treat them as always the same and unchanging for all eternity, because we need a stable reference point against which to measure our own very unstable changes.
That's it perfectly.
Okay, let's just crystallize this before the final synthesis. Based on the source material, we have established two radically different concepts. We need to keep them separate.
Yes. On one side, we have irreversible time-bearing processes. This is the substance of existence. Individual development, aging, memory, complexity itself. This is the phenomenon of having time.
And on the other side, we have timeless periodic mechanisms. This is the tool.
Yeah.
Clocks, calendars, planetary orbits, and any purely deterministic reversible system.
The ability to keep those two concepts rigorously and intellectually separate is the absolute prerequisite for understanding time outside of that old, comfortable, mechanistic worldview.
So, having separated them, we must now define their relationship. How does the irreversible change of my life connect to the timeless periodicity of the clock on my wall?
The relationship is purely one of quantification and coordination. That's it. Humans use the timeless periodic mechanisms, the hours, the days, the years, to assign numerical value to the irreversible changes they experience.
It's just a practical, agreed-upon measuring stick. A year is simply the number of Earth rotations we use to quantify the irreversible growth of my daughter or the irreversible deterioration of my own body. It is utility, not causality.
Exactly. It's a tool for social synchronization. If we didn't quantify our individual time using an external periodic mechanism, we could never arrange to meet for dinner. But the quantification tool is not in itself the definition of the phenomenon. A ruler isn't the definition of distance.
This, then, brings us to the profound mistake, what the sources call the problem of conflation. Where does all our human confusion about time originate, even after we've intellectually tried to separate these two concepts?
The confusion arises when that intellectual separation breaks down in our daily thinking. When people mistakenly believe that the timeless periodic mechanisms, the clock cycles, actually set the pace for the irreversible changes in the individual.
They start to believe that the clock, or the orbit of the planet, causes the irreversible change in us.
That is the fundamental fallacy, and it leads directly back to the idea that time is a large, external, all-pervading force. It's the simple, mechanistic answer that always appeals to our tendency to seek external variables.
So we end up believing this single external force is somehow simultaneously responsible for the periodic mechanisms, like planetary orbits, and for non-mechanistic processes, like our own aging and development.
We project the characteristics of the clock, its externality, its seemingly uniform flow onto the phenomenon of irreversible change, which is fundamentally internal and unique to each of us.
We reduce the complex reality of time-having individuals into a simple, single, measurable variable that we think can be applied universally.
It's an error of category, a profound one.
And this brings us full circle, right back to the time machine. If you accept that conflation, if you really believe that time is an external, universal, measurable, and therefore manipulable force.
Yeah, and the time machine must be possible. Absolutely. If time were a field or a dimension like gravity, of course you could build a machine to manipulate it and run it backwards.
But
But since this philosophical dialogue has rigorously shown that time is individual, irreversible, and emergent from complexity, we have to conclude that the idea of the time machine is rooted entirely in that systematic human misunderstanding.
it's a misunderstanding born from applying a simple mechanistic explanation to a phenomenon that fundamentally resists it.
The ambiguity isn't in the nature of time itself. The ambiguity is in the human impulse to default to the instruction manual for a mechanism, even when we're observing complexity.
We prefer the illusion of control that the mechanistic worldview provides, even if it forces us into these huge logical paradoxes like the time machine.
It's a comfortable illusion.
What a detailed and challenging deep dive into your source material. We have traveled far beyond physics today. We've been defining the ontology of existence itself.
Let's summarize the key philosophical shifts we've achieved for you. First, we established that complexity and mechanism are separated by an unbridgeable philosophical divide. It's a one-way street. Life creates machines.
But machines cannot create life because they cannot grasp irreversibility.
Second, we realized that the machine's inherent inability to process non-predictability leads it to interpret humans as a faulty mechanism, a paradox that proves the limits of its own deterministic worldview.
Third, and this is the big one, true time is not a universal medium. It is individual, irreversible change, rooted in the development and existence of living beings, the Zeitgebende Individuen.
The time having individuals.
And fourth, clocks were just timeless periodic mechanisms. We use them only to quantify this irreversible change, but they do not define or cause time itself. Confusing the measuring tool with the phenomenon is the source of all our temporal paradoxes.
And this offers you a profound shortcut to understanding why the mechanistic worldview, while absolutely essential for engineering and computational success, fundamentally breaks down when you apply it to the realms of life, consciousness, and temporality.
This brings us to our final provocative thought, something for you to really mull over. If complexity, if life is defined by its irreversibility by the time it has, and mechanism, robotics, is defined by its timeless periodicity, then the fundamental quest for creating true, conscious artificial intelligence is not about building a smarter calculator. It's not about faster chips or more data.
It's about solving an ontological mystery. It's about finding the principle that allows you to inject irreversible, unrewindable time into a system that is fundamentally designed from the ground up to be timeless.
What physical or biological principle could possibly turn a reversible, predictable equation into an irreversible, self-developing, time-having being? That is the ultimate scientific and philosophical hurdle.
A great question to ponder as you recognize that the clock on the wall is simply measuring its own repetition, while you are measuring irreversible existence.
We'll leave you with that thought. Thank you for joining us on The Deep Dive.
Until next time.